Hello everyone, welcome to this channel. In this video, we want to talk about some law about resistor, that how we can use them in a circuit. So let's get started. To use resistor correctly in electronic circuits, you must follow a set of rules and principles. These guidelines help you choose, calculate, and place resistors properly in your circuit. In the following, we'll explore this principle with examples. Ohm's law. Ohm's law is the most basic law for determining the resistance value in a circuit. It states that V equals I times R, where V is voltage, volts, I is current by amperes, and R is resistance, and we show it by ohms. Example. Suppose you have an LED that requires 20 milliamps to light up, and you have a 9-volt power supply. To prevent the LED from being damaged, you must use a resistor in series. If the working voltage of the LED is 2 volts, you need to drop the remaining voltage across the resistor. Look at this formula, and then we use Ohm laws. R equals V over I, and we have 350 ohms. So you need a 350 ohm resistor to limit the current in the circuit. Power rating. Resistors have not only a resistance value but also a power rating. This tells you how much heat the resistor can handle before it gets damaged. Power is calculated by P equals V times I, or P equals I power 2 times R. Example, if 20 milliamp flows through a 350 ohm resistor, the power consumed by resistor is, based on this formula, we have 0.14 watts. You should use a resistor with a minimum rating of 0.25 watts to ensure it doesn't overheat. Polarity of resistors. Resistors have no polarity, meaning you can place them in any direction in a circuit without affecting their performance. Series and parallel resistors. Series resistor. When multiple resistors are connected in series, the total resistance equals the sum of the individual resistance. And we have this formula for our total. Example, we have 3 100 ohm resistors in series, so we'll have a total resistance of 300 ohms. Parallel resistors. When resistors are connected in parallel, the total resistance is calculated using the reciprocal formula, like this. Example, 2 100 ohm resistor in parallel will result in a total resistance of 50 ohms. Choosing the right resistor type. Depending on the application, you must choose the appropriate type of resistor. Common types include fixed resistors. These have a constant resistance value. Variable resistors, like potentiometers. Their resistor can be adjusted and are used in applications like volume control. Thermistors. Their resistance changes with temperature. Photoresistors, or LDR. Their resistance varies with light. Example, a potentiometer is used to adjust voltage, while a thermistor is used in circuits that monitor temperature. Positioning resistance in circuits. Series circuit. These are used when you need the same current to flow through multiple components. Example, to limit the current through an LED, a resistor is placed in series with it. Parallel resistors. These are used when you want the same voltage across multiple parts of the circuit. Example, to distribute voltage in a power supply circuit, resistors are placed in parallel. Tolerance. Resistors have a tolerance rating, which indicates their accuracy. The tolerance is expressed as a percentage. For example, a 100 ohm resistor with a 5% tolerance may have an actual resistance between 95 and 105 ohms. Example, if your circuit needs a precise resistance, you should use resistors with a low tolerance, such as 1% or less. Operating temperature. Resistors can heat up in circuits, especially if large currents are flowing through them. It is essential to ensure that resistors operate within their temperature range. For circuits that function in high temperature environments, resistor with a higher temperature rating should be used. SMD vs through-hole resistor. SMD or surface mount device resistors. These are smaller and are mounted directly onto the surface of a printed circuit board or PCB. They are used in compact and miniaturized circuits. Through-hole resistors. These have leads that go through holes in the PCB and are used in circuits that require higher power or larger components. Example, in small devices like smartphones, SMD resistors are used, while in high-power circuits like power supplies, through-hole resistors are preferred. So we come to this conclusion that using resistors properly in circuit design requires an understanding of fundamental laws such as Ohm laws, power rating, and the type of circuit, series or parallel. Depending on the circuit and application, you must choose the right resistor type and ensure accurate values to prevent component damage or poor performance. So if you have any question about the circuit design, you can ask us in the comment, and we answer you as soon as possible. Thank you for watching. If you like this video, please give me a thumbs up and share this video to your friends and who likes to learn about the electronics, especially how to design a circuit. So to the next video, please take care, see you soon, and bye bye.